Hello everyone, in this video we're going to be talking about one-tailed versus two-tailed hypothesis testing. Our first objective is to explain the difference between one-tailed versus two-tailed hypothesis testing. And we'll go back to the example that we used previously of the miracle weight loss drug and its effects on weight loss. So first we need to state the null and alternative hypothesis. The null hypothesis for both a one-tailed and a two-tailed test is going to be the miracle drug has no effect. For a two-tailed alternative hypothesis, it's going to be that the miracle drug has an effect. For a one-tailed, it could either be that the miracle drug is better or worse than placebo. So let's just use better. Miracle drug causes more weight loss. So let's look at a pictorial representation of our distribution. This is a pictorial representation of a two-tailed test. If our alpha is set at 0.05, the probability distribution contains half of the area on the left and half of the area on the right. This means that our drug could be worse or better than placebo. So there 2.5% of the area to reject the null hypothesis within the distribution is on the right, and 2.5% of the area to reject the null hypothesis is on the left. But let's say that I really want to prove that my drug works, so I want to stack all the odds in my favor. I might use a one-tailed test. So let's see what that looks like. So with the one-tailed test, we see we have all of our alpha in the positive direction, which means we have more area to work with where we can get a statistical value that rejects the null hypothesis. It's going to be easier to reject the null hypothesis on this end of the spectrum using a one-tailed test. However, we can't reject the null hypothesis in the opposite direction at all. So there's no way for us to tell if the drug is necessarily worse than placebo with a one-tailed hypothesis in the beneficial direction. And this is actually going to affect the specific test statistic that you need. Let's use the t-test as an example, and we'll go to our t-table and we'll see what the difference in critical value is between a one-tailed versus a two-tailed test. So here's just a portion of the t-table, and let's look at the critical t values for 2 degrees of freedom, which is going to be this row. And we'll first start with our two-sided alpha of 0.05. We would need a t statistic greater than 4.3 or less than negative 4.3 to reject the null hypothesis. For a one-sided alpha of 0.05 with 2 degrees of freedom, we would only need a t-statistic of 2.92 to reject the null hypothesis, which makes it easier to reject the null hypothesis using an alpha of 0.05. But remember, we won't be able to detect if the drug is worse than placebo. And that's why most new drug approvals require that a two-sided hypothesis test is used. So you should be concerned if you see a new drug study come across and you see that they're using a one-tailed hypothesis test with an alpha of 0.05. They won't be able to tell if the drug does worse, and they're really just stacking the odds in their favor.